Okay. The pedestrian walks at the rate of the square root of the difference of a number and 4. The square root of difference. Difference, square root of the entire difference. Not square root of x, and then from that square root you subtract 4. Because it's square root of the difference. If it was the difference of the square root of a number, then that would have been correct. And the other one, a bicyclist's speed is the square root of the sum of 4 times that number x and 1. So we make a little table. Rate times time equals distance. Rate of the pedestrian, rate of the bicyclist, time 4 hours, 2 hours. Multiply the 2, you get the individual distances. And you were told that the sum of the distances is 34. Isolate the square root by subtracting 4 square root of x minus 4 from both sides. Square, you no longer have a square root here. Distribute, subtract 1154 and subtract 16x from both sides. The 16x's drop out completely. And we have a square root again. Square both sides. X looks like 20. We want to check that. If x is 20, we crank it in and it comes out correctly. So the speed of the pedestrian is 4 miles per hour. The bicyclist speed is 9 miles per hour. Now we only got one answer here. Okay. That's number 1. Number 2. We have the man's shadow per man is to the pole's shadow to the pole. And I suspect this is x, the shadow of the man. So it's a square root of x. The square root of x is 5, a square root of 15x plus 16 is 20. You could multiply both sides by 5. You could multiply by 4, both sides. You have isolated the square root, square both sides. You get x, which is 16. The man's shadow is the square root of 16, or 4 feet. Now we need to check the 4 feet, and it looks like it is coming out. Example, exercise 3. We have 25 feet as the hypotenuse of a right triangle whose legs are square root of x and square root of 8x plus 73. Again, a diagram would have been handy. The sum of the squares of the legs equals the square of the hypotenuse. Square both sides. Correction. Square this square root, square that square root, crank it out. X is 144. And 144 checks out, so that's a root, that's an answer. And then the wall is 3 times 144 plus 73, or 35 feet high. The painter takes square root of x hours to paint a room or whatever he paints. His assistant does it in 1 more hour, no, in 2 more hours. That should be 2. And this comes out to be 12 over 5, 10 plus 2, 12 over 5. The reciprocal is 1 over square root of x, 1 over 2 plus square root of x. That 2 is correct. That should have been a 2 here. And the reciprocal, 5 over 12. This is the portion of the job that is done in 1 hour. So what the painter does by himself plus what the assistant does by himself is the same as what they both do together in 1 hour. So I have the equation, multiply by the least common denominator, which is 12 times x times a quantity, 2 plus square root of x. The square root of x drops out, this 2 plus square root of x drops out, and the 12 drops out. Distribute, collect like terms, isolate the square root. Again, square both sides, and you come out with this particular quadratic. Hopefully, it is factorable. So it's a cookbook problem, of course. You find your magic numbers, you crank it through, x is either 16 or 36 over 5. We want to check 36 over 5. Okay. Yeah, 36 over 5. And 36 over 5 over 25. You take the square root, you crank it out, and you are supposed to get the left side is not equal to the right side, so this is not a solution. Then you check x, which is 16. If x is 16, you crank that through, and if that is correct, it takes the painter by himself 4 hours to paint the room. Now, is this really a solution? I didn't check it. Yes, I checked it right here. That's it.